Hello friends, welcome once again to Sin²α online math class. In this video, I'm going to prove to you that sin² plus cos² is equal to 1. In the previous video I uploaded about trigonometry, you will see where I utilize this particular trigonometric rule, which tells us that sin² plus cos² is always 1. You're going to understand this from this triangle I'm going to draw. Okay, so take a look at this right angle triangle. This is the right angle. The right angle is always 90 degrees. So you can choose to put an angle either here or here as the case may be. So if I want my theta to be here, it means that any side facing the angle is opposite. Then this side is adjacent to this particular angle. This is the opposite to your angle is facing it. Assuming I put the angle here, it means that this side will be the opposite to that angle because the side facing your angle is the opposite. Okay? Then if here is now the angle, then here is opposite and here is adjacent. Then the longest line or the side facing the right angle is the hypotenuse. Now supposing I call here A, the hypotenuse, and call here B and call here C. You understand from trigonometry ratios that sin theta, if you use the acronym cos²α, you understand that sin theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. I don't need tan in this case because I'm giving sine and cos here. So let me leave tan alone. So if I want to get my sin theta, you've seen that sin theta is opposite over hypotenuse and the opposite is B all over hypotenuse, which is A. If I'm to get cos theta is adjacent, which is C over hypotenuse, which is A. This is cos theta and this is sin theta. Now remember your Pythagoras theorem, which is telling us that the square of hypotenuse is equal to the sum of the squares of opposite and adjacent. So from here, hypotenuse squared from Pythagoras is equal to opposite squared plus adjacent squared. This is our Pythagoras theorem. Now, you know in equation, whatever you do to the both sides will not affect this equation. So let's divide both sides by a squared now, over a squared over a squared. So that if a squared divide a squared, it will give us 1 equal to b squared over a squared plus c squared over a squared. Do you know I can first of all write this side before the other side? And I can call it b squared over a squared plus c squared over a squared is equal to 1. Now, from the laws of indices, this square is common, so you can write b over a all squared plus c over a all squared is equal to 1 because the square is affecting everything. And from here, what is our b over a? Our b over a is sine theta, so I will write sine squared theta because of this squared plus what's our c over a? C over a is cos theta, so I will write cos squared theta because of this squared equal to 1. So you've seen that we have proved it that in all cases that sin² theta plus cos² theta must, not even will, must always give you 1. Thank you for viewing and may God bless you.